Okay, so our work is titled Information System for Detecting Low-Flying flying air targets and predicting their trajectories. So image recognition is used in various fields, including military, security, medical, manufacturing, etc. Such tasks include clustering, image classification, and object tracking. For some of these tasks, it is important to capture and predict object trajectory. In recent time, Ukraine's air defense needs to fend off intense combined air attacks. That includes kamikaze drones, cruise missiles, ballistic missiles, hypersonic missiles, and possibly other targets. Such intense attacks can deplete air defense capabilities and finally reach their target. One of the main problems with these attacks is the use of kamikaze drones. They are cheap and hence they are mass-produced and mass-used. They are relatively slow, and it means that it is impossible or very hard to hit them with conventional airplanes, modern airplanes, because of very intense difference in their speed. They are relatively cold, and it renders infrared homing completely or quite useless. They have a low radar cross-section, and it means that they are hard to detect. Moreover, they can circumflex the terrain, hide in the folds, and that all lead to depletion of air defense. That means that we need to imagine to find a new and cost-effective system for fending off such targets. So this research aims to develop an information system for detecting low-flying air targets and predicting their trajectories. The overall system overview is presented on this image. So it consists of, besides objects that we are trying to track, technical vision system, motion control system that controls vision system and also control the device for object interaction, and part of software that control the motion control system and also process information from a technical vision system. All this is we use look-back feedback in order to track the object and be able to combat it. We develop a prototype and sample software that is able to track the recognize and track the object that we are looking for. On this image, on this illustration, you can see thermal images of model objects and green square that indicates tracking of that object while it is moving. Graphical on the slide, you can see a graphical representation of the results of determining the object contours and the way we can track and determine this object. So finally, we can say that we are the development of the system for recognizing objects by their thermal images. Special software processes the data from the thermal image camera, calculates the deviation of the image from the observer center, and sends the control action to the motion control system. That helps us to track the object and to keep it in the center of field of the view of the thermal image system. The application of visual control methods makes it possible to adapt the operation of the device due to the widespread use of visual information about the state of low-flying air targets and prediction of their trajectory. Thank you.